Good morning, one and all. Myself, Stuti Ahuja. Today I will be presenting my paper, Leveled Approach of Context Setting in Semantic Understanding of Remote Sensing Images, paper ID 4248. Track is Signal Processing. Okay. So first of all, we need to understand what is semantic understanding of remote sensing images. As we all know, remote sensing images carry a lot of geographic information. To extract this information, first we need to identify what objects are present in the image, then what is the relationship between these objects, and then based on these objects and their relationships, we need to generate descriptions in the form of sentences. So this is all about semantic understanding. Few approaches are proposed in literature. A few significant approaches are listed here along with their data set and their contribution in this particular area. Even though existing methods generate descriptions based on some deep learning models and the sentences which are used to train that model, but these descriptions describe the content of the image, but overall context of entire image is still missing. To overcome this limitation, leveled approach for context setting is proposed in this paper. So this is the proposed level approach for context setting. So first step is scene classification. So this scene classification is assigning a single label to entire image. So exactly the scene represents which particular class. Then multi-level classification. Now after identifying the entire scene label, we need to tell about what are other objects present in that particular image. So using multi-label classification, we are assigning multiple labels to that image in the form of keywords. Then third step is object identification with bounding box. To get the exact location of those objects, we need to find out the objects with surrounding bounding box. Then fourth step is description generations based on directional relations. So there are three types of geospatial relations: topological, directional, and proximity. So in this paper, we have used a directional relationship identification. And based on directional relationships, descriptions are generated. And finally, in the last step, we are combining all these descriptions generated in every step and giving a detailed sentences telling about what are the contents in the image and what the image is about. So first step is scene classification. To perform scene classification, we have used NWPU, this RESISC 45 dataset, which contains 45 scene classes and total 31,500 images with various resolutions. So this dataset is trained using basic Keras sequential model and ResNet-18 model. So these are the results generated using Keras sequential model, and these results are generated using ResNet-18 model. These are sample results. So upper label represents ground truth and lower represents the predictions which are generated by this particular model. The performance analysis is carried out based on the entropy loss. So if we see the accuracy of Keras sequential convolution neural network is only 54%, but ResNet 18, when used under fast AI framework, it is giving 91%. So ResNet 18 is preferred for scene classification. Then second step is multi-label classification. So for assigning multi-label classification, UCMerced Land Use dataset is used, so which contains 17 classes. So these 17 classes are used, and based on this dataset, ResNet-50 and AlexNet is applied under fast AI framework. So for ResNet-50, the results are shown in this particular slide. And if we see the performance analysis of AlexNet and ResNet-50, so both are giving very good accuracy, 95% and 96% when used on UCMerced dataset. Third step is object detection with bounding boxes. So lot of datasets are available for this particular task. So we have used DIOR dataset, which has 20 object categories and maximum images out of all these datasets. That is 23,463 images. And we have trained this dataset using YOLO V5 object detection model. So these are the results generated after training this model using YOLO V5 object detection. And performance analysis, when we have calculated precision recall and MAP, that is mean average precision. So accuracy of this particular model for all the classes combinedly is around 62%. Then fourth step is description generation based on relationships. So here we have focused on directional relationship, and proximity relationship is also calculated. So directional relationship is calculated based on the centroid of these objects. So after identifying the objects and their location in the form of this bounding box, which is a rectangular shape, we have calculated the centroid of each object, and based on the centroid, relationship is identified, point to point a relationship which is directional as well as proximity. 8 directions are considered, and for every object, like here storage tanks and chimneys are detected, so every object relation with other object is calculated. And template based sentence generation is used. So template based is object 1 is on the relationship and of the object 2, means template is used for generating sentences. So we can also use natural language generation libraries like Simple NLG, which gives better grammatical sentences. And proximity is based on distance. So as compared with this image size, we have to find out the distance between two centroids, and we need to compare it with diagonal of this image. And if it gives greater than 0.5 value, means it is far from other object, and if it gives less than 0.5, then one object is near another object. So near and far two proximity relations are calculated. And in the last step, we are merging all the sentences together and generating a detailed description. So first sentence shows the overall contents. Image shows thermal power station. Second sentence shows multi-level, result of multi-level chimney and storage tank. So it contains, again, template-based sentence generation is used. From data frame directly, sentences are generated by using the template. Then directional and proximity relations are shown in the form of sentences. This is all about leveled approach for context setting, which comprises scene classification, multi-level classification, object detection and labeling, then description generation using geospatial relationships. Here we have tested for directional and proximity relations, but topological relations can also be used here. And finally, combining all the descriptions together to give one paragraph of sentences. When we have classified entire scene using scene classification, we have used ResNet-50 and dataset used is NWPU 45 with 45 classes. And when applied to same dataset, this technique outperforms other machine learning techniques with 91% accuracy. Then for multi-level classification, AlexNet and ResNet-50 is used. Both are giving around 96% accuracy on UCMerced 17 class dataset. Then object detection and labeling is carried out for positioning the particular object in the form of bounding box with YOLO V5 with 20 class DIOR dataset, which is giving 62% accuracy. It is still comparable with other techniques which are used in literature for object detection using for bounding boxes. And directional and proximity relations have been identified and represented in the form of sentences, and detailed description and context setting is achieved using leveled approach. These are all the references which we have used for this particular work. Thank you.